Hi everyone. So in this video, we are going to solve Leetcode problem 2654, minimum number of operations to make all array elements equal to 1. Okay. Now let's read the problem statement. You are given a zero indexed array nums consisting of positive integers. You can do the following operations on the array any number of times. Select an index I such that it is within the range of 0 to n minus 1, where n minus 1 is not included, and replace either nums of I or nums of I plus 1 with their GCD value, greatest common divisor value. Return the minimum number of operations to make all elements of nums equal to 1. If it is impossible, return minus 1. Okay. So now let's take this example and let's figure out that how it is solved. So we have, just a second. Yes. Yes. So we have 2, 6, 3, and 4. Okay. We have to make all ones. Okay. So now if we want to make all ones, then what I'll do is I'll just do GCD of this first. That will give me 1. Okay. 3 and 4 GCD of 3 and 4 equals 1. Then I can replace either this or this by 1. So let's say I replace this by 1. Now if I have single 1 in my array, then I can spread it across my entire array. That is, we will pick these twos, then we will GCD of 6 and 1 will be 1. Then I'll replace this by 1. Similarly, I'll do with this. Similarly, I'll do with this. So that tells us that we have first case is case 1, single 1 in array. So what will be the answer? If we have single 1, then we only have to spread it across our entire array. That's the number of operations will be n minus 1. Okay. Similarly, if we have multiple n's, let's say k ones in array, so our answer will become n minus k. Okay. Now the question comes, if we don't have any one in our array, like in the given test case, we didn't have any one in our array 2634. So for 2634, what we did was we found a pair which resulted in whose GCD resulted in 1. Okay, but there can be a scenario in which we don't have any pair. We will have to find out the subarray in that case. Why subarray? Because in this we are taking GCD of intermediaries of consecutive elements only. So let's say the 3 and 4 GCD doesn't return 1. Okay. So then in that case, what we will do is we will do GCD of this result k with 6. Okay. For example, let's take one example so that you can understand better. For example, 6, 10, and 15. Okay. Now in 6, 10, and 15, if we see 10 and 15 GCD is 5. 6 and 10 GCD is 6 and 10 GCD is 2. So we don't have any single one in here. Okay. But if we take the GCD of the entire subarray, that is first 10 and 15 and then 6. So it gives us 5, and then 5 and 6. This gives us 5, and then 5 with 6. This gives us 1. So that means we can achieve 1 by, we have to find out the shortest subarray. We have to find out the shortest subarray whose GCD equals 1. Okay. Now let's say let's write case 3 now. No ones in array. Okay, then what we will do, we will find shortest subarray whose GCD is 1. Okay, now performing GCD on this entire subarray, in how many operations we will perform the GCD? So for example, here we had 3 elements. So we did perform operation 3 minus 1 times, 2 times, right? First of all 10 and 15 and the result of 10 and 15 with 6. So we performed 2 times. So this will result in let's say this value is k. So operations, how many operations? K minus 1 operations. So k minus 1 operation will result in single one. So this will generate one single one in the entire array. Okay. So that means we number of operations that we performed till now are k minus 1. This resulted in one single one in the array. Now we have to populate this one in the entire array. Okay. So now if we have to populate the generated one in array, how we will populate it? We will populate it in n minus 1 times, right? This is just similar to the first case that we discussed, right? For example, let's say the value of k is 0. If and only if the value of k is 0, then in that case we cannot populate 1 in the array. So in that case our answer will be -1. Okay. So now what we will do? What we will do? We will first of all count ones. If let's say this is CT, if CT is greater than 0, return n minus CT. Okay. Otherwise, what we will do is find shortest subarray with GCD equals 1. Let's say this is k. So if k equals 0, return -1, else return. So k minus 1, this is the first step, and then we have generated single one in the array. Now we have to populate it in the entire array. So that will be n minus 1. N minus k minus 2 will be the answer. Okay. I hope you understood the solution. If not, I'll recommend you to rewatch the video. Okay. Now let's move on to the solution part. Let's write the code. Int ct is equals to 0 for auto num of nums. If num is equal to 1, if count is less than greater than 0, then we will return n minus count. Else, what we will do is we will find the smallest subarray with GCD 1 and we will pass nums here. If we see the nums of length is 50 only, so we can write nested for loops here. There is no problem in that. So once we have this value sm, then we will check if this is 0, then return -1. Otherwise return, if you see here, what we need to return is n minus k minus 2. So k is nothing but sm. So let me just replace sm by k so that we understand better. Okay. So if we see here now, so it is n minus, sorry, it is not n minus, it is n plus, right? So n plus k minus 2. Now our only job is to write this private method vector int ampersand nums. It is very important to write ampersand here. In this case, it will work if we don't write as well, but it is recommended to write ampersand anyway. So let's say by default, the smallest length is n plus 1, which is not possible, so that at the end we know whether we were able to find it or not. Not n. So here, let's write nums dot size. Let's write a nested loop here. Let's create a GCD variable here. GCD variable will be nums of, will initialize it with nums of r, nums of I. Now GCD value is equal to, we'll use the standard template libraries method underscore underscore GCD, passing the two required parameters, nums of j. We will see if GCD equals to 1, we will do k is equal to min of k comma j minus I plus 1. That will be the length of the subarray that we are considering right now. Now we don't need to stretch this subarray, so we can break it also when we find GCD is equal to 1, and then we can start with the different starting point, right? So here we break, here we return k at the last. Here we have uh, here we should also write that if k is equal to n plus 1, then return 0. Okay, and otherwise return k. Now let's run and hope our solution works. Okay, it is showing problem, it is showing n, so we don't have n declared here. So what I'll do is I'll simply write n is equal to nums dot size, run the solution. It is working fine for the sample 2 test cases, and because we have done everything right, we are sure that it will work for entire solution. So yeah, our solution is accepted. This is the solution. This is the solution, and I would also like to mention that we can also improve the code here. Improve the code by saying that, let's say we can write here, it returns -1 here in this case, not 0. So what we can do is we can directly return, this here. Let's rerun the solution. So it is giving problem here because I must have, yeah, sorry. So here, because we are entering the returning this and not n plus k minus 2. So okay, let's keep it like this only. Let's keep it like this only. So yeah, so this is the solution. Rerun it. It is working. And yeah, also in this C, I have created the relevant names here. The name is not anything. The names are relevant. The names are very important because when you will be writing production level code, it is very important to write relevant method names. So please keep a practice of it and try to write clean code even in the contests so that you build a habit and not just you are tied up to writing good code in the production level. Try writing the good code in the DSA for solving problems. So that's it from my side. Have a good day and enjoy.